children. In today's video, we will be continuing exercise 7.1 of cube and cube roots. In my last video, I have explained you question number 1 and 2. In today's session, we will be doing question number 3 and 4. So if you see question number 3, find the smallest number by which each of the following number must be divided. So in question number 2, it was by which the number has to be multiplied to make it a perfect cube. Here we have to divide it. So whatever your triplets will not be there, with all unwanted numbers we will divide the given number. So the first thing, as we have done earlier also, we will do the prime factorization. 3 2s are 6 and 3 7s are 21. Now 27, if you divide again, 3 9s are 27. This is again divisible, 3 3s are 9 and 3 1s are 3. So if you see, I am getting a perfect triplet of 3, but this 3 is unwanted, right? It is not forming a triplet. So it means if I divide the given number, 81 is giving you the factor as 3 into 3 into 3 into 3. So this is forming a perfect triplet here, but this 3 is unwanted. So if you divide both the sides by 3, this is cancelled. What it will be? 27. And 27 will be equal to, you see, 3 into 3 into 3. It gives you 27. It means the given number will be 25 if you divide 81 by what? 3. So what will be my answer statement? How we will write? We should divide 81 with what? 3 to obtain a perfect cube. So this is just the reciprocal of question number 2, in which we have question number 2, we have multiplied with the unpaired numbers to make it a perfect triplet. Here we will divide with all the unwanted numbers to make a given number as a perfect cube number. Okay. So let's do part 2 of the question. If you see, the next number is 128. So the first thing, as we did earlier also, we will do the prime factorization of 128. 128. So the unit place digit is 8. It means the given number you can divide by 2. 6 are 12, 2 4s are 8. Again 2 3s are 6, 2 2s are 4. Again 2 1s are 2 and 2 6 are 12. Now this is 2 8s are 16. This is 2 4s are 8. This is 2 2s are 4 and 2 1s are 1. Again, if I start making the triplets, a perfect triplet of 2, another perfect triplet of 2, and this 2 is unwanted, right? So if I write the factors of 128, I am getting a perfect triplet of 2, then I am getting another triplet of 2, and I am getting a 2 here, right? So this is a triplet, this is a triplet, but if I divide the given number by 2, it means I will get a perfect cube number. So what we will write? We should divide 128 with 2 to obtain a perfect cube, right? I'll show you how. Your factors were 128 is equals to 2 into 2 into 2, then another 2 into 2 into 2 and a 2. I said that you have to divide the given number by 2. So if you divide both the sides by 2 here, this 2 is cancelled and this becomes 2 6 are 12 and 2 4s are 8. So 64, right? And this is also 2 2s are 4, 4 2s are 8, 8 2s are 16, 16 2s are 32 and 32 2s are 64, right? 2 2s are 4, then 4 2s are 8, 8 2s are 16 here, and then 16 2s are 32 and 32 2s are 64. So you get 2 cube into 2 cube. So 64 is a perfect cube number if you divide 128 by 2. Okay. Now the third part of the question is 135. All parts are same. You should pause the video and try to solve the questions on your own. If you are stuck, then only see the solutions. Now the number is 135. 135 we know is also divisible by 5, but before that 5 plus 3 plus 1 is 9. It means the number is also divisible by 3. 3 4s are 12 and 3 5s are 15. 3 1s are 3 and 3 5s are 15. This is again 3 5s are 15 and 5 1s are 1. So let's see a perfect triplet of 3. this number 5 is not even making a pair, right? So it means we will write the factors of 135 as 3 into 3 into 3 and this 5. So if what should your answer statement? Hence we should divide 135 by 5 to obtain a perfect cube, right? And we can see that. How we will do that? If I divide both the sides by 5, this is cancelled. What this becomes? 5 2s are 10 and a 17. On the other side it is 3 cube. 3 into 3 into 3. So it becomes a perfect cube number. Okay. There are two more parts in the questions which we will be solving in the similar way. Next part is 192. It means we have to do the prime factorizations of 192. Start with 2, 2 9s are 18 and 2 6s are 12. Then again 2 4s are 8, 2 8s are 16. Then again 2 2s are 4, 2 4s are 8. Again keep going till you get a 1 and then 3 1s are 1. So here it is very much clear, a perfect triplet of 2, another triplet of 2, but you are not getting a triplet of 3 here. It means when I write the factor of 192, perfect triplet of 2, then another perfect triplet of 2 but a 3, right? So hence we should divide 192 by what? This is a triplet, this is a triplet. If I divide the given number by this 3, I will get a perfect cube number. So hence we should divide 192 by 3 to get here to obtain a perfect cube. This is how we write. And let's solve it also. If you divide both the sides by 3, this is cancelled. What this number will be? 3 6 are 18 and 3 4s are 12, right? So this is also 2 2s are 4, 4 2s are 8, 8 2s are 16, 16 2s are 32, which gives you 32 2s are 64. So it means if I divide 192 by 3, I will get a perfect cube number. Okay. So before you see the last part of this question, it is 704. Okay. 704 I really want everybody to solve on their own. The fifth part is 704. Before you see the solution, try to pause the video and solve it on your own. Then you can verify your answer. So it is again divisible by 2. 2 3s are 6, 2 5s are 10 and a 2 2s are 4. Go 2 1s are 2, 2 7s are 14 and 2 6s are 12. Then again 2 8s are 16, 2 8s are 16. 44, then it gives you 22, then it gives you 11 and 11 ones are 11. So again you are having a triplet of 2, you are having a triplet of 2, but this 11 is extra, right? So the factors of 704 will be a perfect triplet of 2, then another perfect triplet of 2 and into 11. So you see, if you divide the given number by 11, you will get a perfect cube number. So how do we write? We should divide 704 by 11 to get a perfect cube, right? So this was question number 3 of this exercise. Now the last question of this exercise is a word problem. Let's see that. The last question of this exercise is, Parikshit makes a cuboid of plasticine of sides 5 centimeter, 2 centimeter and 5 centimeter. So the sides are given as 5, 2 and 5. It's a cuboid, which means the length of the cuboid is 5 centimeter, the breadth is given as 2 centimeter and the height is given as 5 centimeter. How many such cuboids will he need to form a cube? So he needs to make a cube, right? And how many such cuboids will be needed if he has to prepare a cube out of it, right? So perfect cube means the number should make the perfect pair of the perfect triplets, right? So the volume of cuboid is what? L into B into H. which means 5 into 2 into 5, right? This much centimeters cube. But you see, now we have to observe 5 is a pair, not a triplet. It means I have to multiply the given numbers, which is 5 into 2 into 5, with a 5, and then this 2 is a single. It means I have to multiply with two 2's. So this is something extra additional we are doing to make it a perfect cube number. So 5 into 2 into 5 was the volume, but to make it a perfect cube, as the Parikshit has to make a cube now, we have to multiply it with 5 into 2 into 2, right? So this much is how much? 5 into 2 into 2 is how much? 20 cuboids, right? So what will you write? Hence 20 such cuboids are needed to make it a perfect cube. So this is a cuboid with these dimensions. Now we have checked with what numbers you will multiply with it. That gives you 5 into 2 into 2, which means 20 cuboids are required to make it a perfect cube. Okay. So with this question, this exercise is finished. Okay. Please do watch my next video for the solution of exercise 7.2. Till then, take care and bye everyone.